Good. Mic works. Okay, yeah, I guess we can go ahead and get started. It's the after lunch session, but looks like we have lots of people here promptly, so hopefully don't expect too many stragglers. I'm going to be talking today specifically about running standalone applications on Cloud Foundry. There's going to be some web apps in the mix as well, but this is mostly just kind of a really deep dive into the types of standalone applications that we now support on Cloud Foundry. And I actually realized as I was putting this together that we are going to attempt in this session to push 11 separate applications. So it's going to be very action-packed. We'll see if we can get it done in the time allotted. Some of them are smaller parts of composite applications, but when you get down to it, it's going to be 11 pushes to Cloud Foundry. So just really briefly, who am I? For those who weren't, I just did the last session, What's New in Cloud Foundry, and I see some familiar faces, but I've got lots of new faces too. So for those who aren't familiar, I'm an engineer on the Cloud Foundry team, focusing specifically on support for frameworks and runtimes. So most of the stuff that you as developers interface with, our team is responsible for. And I've been with SpringSource for a long time, and actually I was saying earlier that I'm on a streak. I've been to every Spring one. The first two as an attendee and then speaking at all the subsequent ones, so pretty happy about that as this is now the 8th. And there's my contact info, so feel free to find me on Twitter or email if you have any questions after the session, or come find me at the Cloud Foundry booth or in the lounge. So to start out with, I kind of just want to figure out where everybody is. Who is familiar with Cloud Foundry, used it or went to boot camp or knows a good deal about it? Okay, most people in the room. That's excellent. I'll do a really brief intro, try to keep it short for those who already know, but just to kind of get everybody up to the same page before we start diving in deep with specifically standalone application support. So this is kind of our standard intro slide. You've probably already seen it a few times if you've come to any of the talks so far. But this just kind of in a nutshell represents what Cloud Foundry is. We are the first open source platform as a service. So Apache 2 licensed, everything is on GitHub for your perusal. And basically we use this triangle to talk about Cloud Foundry. With the top being kind of all the frameworks and runtimes we provide support for. So if you write your applications in Spring, Rails, Node, Scala, chances are you can deploy it onto Cloud Foundry. And then, of course, we provide services like data and messaging services as well. And then on the right-hand side, the cloud provider interface, this basically is just kind of illustrates how people utilize Cloud Foundry. So as I mentioned, at its root, it is an open source platform as a service, which means it's deployable in a number of places. So we aim to be infrastructure agnostic, so you can take our core code base and deploy it to a private cloud. Of course, we have our public cloud, which is cloudfoundry.com. If you've been to the booth, hopefully you've signed up for a free account there. But that's just one of the many incarnations of the code base. We also have what we call microcloud, which is basically a downloadable VM. So you can run all of Cloud Foundry on your laptop for yourself privately. So a number of different deployment options when we talk about Cloud Foundry. It's not just our public.com offering. So actually, before I even start discussing this, what I'll do is a quick hello world, just so you guys can kind of get a feel for pushing an application to Cloud Foundry. Like I said, you're going to see a lot of it, but just before I start talking at you, it might help to get you familiar with the landscape. As I mentioned in my last session, this is also the super secret key to getting a hoodie from our booth, because you do need to show a Hello World app. So I'm going to show you a really easy way to do that. You just go up to the booth, do it yourself, get a hoodie. Be great. I see several people wearing them already, which is awesome. So I'm going to go to STS actually and just create a quick template project for a Hello World. So we'll do new Spring template project, and I'll go with the Spring MVC project. We'll call it Hello World. Okay, and just give it a top level package. So actually I lied, I'm doing 12 pushes, hopefully, in this session. And Maven's been complaining a little bit, but we'll ignore it. And let me just configure the working set real quick so we can actually see that project we just created. Okay. So this is just a really basic MVC project. We see that we kind of got everything set up for us by default, including a controller, which essentially just at a root request tells us welcome home and what the client locale is and the date. So nothing too fancy, but fancy enough to get a hoodie out of. And of course, we have a command line tool that you can deploy applications to Cloud Foundry with, and I'll be showing that a good bit as well. It's called VMC. But this time I'll actually just use the STS support since we're already in our IDE. Why not deploy to the cloud in our IDE as well? So for those familiar with WTP, basically you can create a Cloud Foundry server the same way that you would have, say, a local Tomcat server. So you can just drag and drop your applications to it. And I've actually got this one hanging around from my last demo. But we can delete it real quick, so I can just walk you through how to do that. Okay, so if I right-click on servers and select New Server, I will get a Cloud Foundry type. We'll call it cf.com. Okay, and here it gives me a drop-down that kind of allows me to choose which cloud I want to target. So as I mentioned before, there's a number of different options. We're going to go with the public cloud this time, which is just api.cloudfoundry.com, but you can see I could also have my own microcloud VM running, which I'm actually going to be using later to demo as well, and I can show you a little bit of that. So I'm just going to enter my credentials here, which you can get with your free sign up at the booth. Validate the account real quick, make sure I entered it correctly. Account information is valid, that's great, and let's just go ahead and create that. So now I've got this server handy and ready to be deployed to, so I can just take my Hello World app, drag it down here, drop it, and I get a pop-up. So basically here it's just listing the various web frameworks that my app might fall into, and it's correctly detected that it's a Spring application. And then I can choose either Java 6 or 7. 6 is fine for now. URL it assigns me, which is changeable, and actually I do need to change that because as I found out last session, surprisingly, Hello World is taken. Who would have thought? So let's go with Spring 1 container. Okay, memory settings, 512 is fine for default. Okay, and then here if I wanted to provision any data or messaging services, I could do so. You'll definitely see this a little bit later on. So for now I'm just going to click Finish. So this is actually going to take my application and deploy it out onto Cloud Foundry, and in a second we should see the application log output showing up on the console. There it is. So it looks like it's up. And if we double click on the application, we can get kind of a detailed view here of our Cloud Foundry landscape. So all of our current applications listed, all of our services. And over here for the selected application, you can see that I'm able to click on the URL, and then of course I could also change memory and scale up, all of which we'll see later. And there we go. There's our quick Hello World. So that's a really quick intro there into Cloud Foundry, and we'll be doing some more complex apps as we go through, but just to give you an idea before I start talking. Okay. So you just saw basically our support for deploying Spring apps, but we also offer a number of other runtimes and frameworks that we support out of the box, and I'll explain a little bit more about what that means. This is pretty much everything that we have right now in terms of frameworks on .com side, and most of these have been around since we actually released, with the exception of Play, which is relatively new, and Rack for Ruby. Both of those, I think, are within the past year or so, recent additions. And then similarly in the open source code base, we have a number of community and partner contributions. So if you were to take the open source code and run it on your own Ubuntu VM, you could actually use Python, Erlang, and PHP. We have partners for Python and PHP that actually offer commercial support. So they're running the Cloud Foundry code base in their own data centers, and that's AppFog and Staccato. And there's also .NET support. Another partner is providing that with Iron Foundry. That's not in our open source code base, but accessible via the Iron Foundry side. So you can see we've actually worked with a number of different partners as well as the community to provide a lot of the runtime and framework support that we have along with just the core components. And when we're evaluating whether or not we actually want to support a framework, we live by what's called the platinum rule, which is basically, we look at each framework and specifically see, what do we want to do to support this framework? What kinds of things are unique to this framework that we could do? For example, who develops in Node? Do we have any Node.js developers? Anybody familiar? Not too many Node developers. Okay. Well, Node has a module packaging dependency management system. And if you were to deploy a Node app, we would actually take care of downloading your dependencies for you and making sure they're installed. That's kind of just one example. There's many, many different examples for each of the frameworks of things that we do that are specific to your framework to make your deployment experience easier. And there's a number of common things that we do for all the frameworks that we've supported. So, making sure that you have a command line to do the things you need to do, apps, services, memory, scaling. We also provide environment variables that you can use within your application to access any services that you might use. And then we try to go a step beyond that and provide runtime libraries. So if you don't necessarily want to look at the environment variables and parse the JSON that's in them for the services, we provide a number of utilities basically where you can programmatically create service connections. The Spring support in particular is really nice for that. We have namespace bindings. We'll talk a little bit about that later. Another thing that we typically do is what we call auto reconfiguration. You may have heard us talk about that. In fact, we did a whole session on it last year. But in a nutshell, that's essentially just, for your more common applications, Spring web apps included, we want you to be able to take an existing application, even if it's connecting to, say, an in-memory database or something running on localhost, a MySQL running on localhost. Take this application without modifying it and push it to Cloud Foundry. This is just a really quick way to get you started. So essentially what we try to do is, in the most common cases that we know of, we can automatically reconnect your application to the data services that you provision. So if you push an app and you say, I want a MySQL service, and your app is not talking to that MySQL service with that URL, that kind of magically happens for you on Cloud Foundry. Of course, that's fully controllable by you. You can disable that behavior. You can take control of the service access yourself. But this is just a way that we provide to get you quickly started. And similarly, we offer access to services, and we'll show that a little bit later. So direct access to your MySQL data, et cetera, through your local clients, like the MySQL command line tool that you're used to. And manifest support, which we'll also see. This is just kind of a way to use our command line tool with files that provide all the interactive data it needs to push your application. So far, everything I've told you is kind of standard Cloud Foundry stuff, framework, runtimes, VMC, et cetera. And this serves a good majority of people. But we were definitely finding that there was a number of use cases people were asking for things that didn't really fall into any of these frameworks. And this happened, I guess, around late spring that we started taking a look at, how can we support things like workers, some of these newer web frameworks that kind of start up with a main, that type of thing. So we added what we call the Standalone framework, which is actually kind of not a framework, so it's a bit of an oxymoron. It's the no framework framework. But basically what this means is if you've got any kind of package of bits, anything that you want to deploy, package it up, push it out to Cloud Foundry, choose one of our provided runtimes, and tell us how to start it. So in this example, basically, you're pushing out your application binaries, you're saying I want a Java runtime, and then you're just providing us a Java command to run. You could do scripts, Java commands. We'll see a number of different options here. But basically, this is kind of a way to run the things that we don't provide explicitly framework support for. And we're going to talk a lot about the different use cases for this. And this covers a surprisingly large number of things that you might want to do that you weren't previously able to with Cloud Foundry. Okay, yeah.
Do you mind questions as we
No, questions are fine.
Can you go back one slide?
Sure.
So it's a standalone, so it's a no framework.
Mm-hmm.
You're still given a choice of Java, Node, Ruby.
Yeah, so the question was about choosing the provided runtimes. So the frameworks are things like, Spring or Rails or something like that. And then as of right now, for Standalone, we do require that you use one of the runtimes that we provide. Yeah, we are looking very, very high level at potentially allowing you to have your own runtimes and push them eventually, but we're not there yet. So we kind of started with bring your own framework essentially, and then we'll move on to bring your own runtime. So this still covers a lot of the cases, but yes, adding a new runtime is a separate story. Okay, so we're going to talk about 4 major categories of standalone applications today, and the first one that we're going to start on is asynchronous web frameworks. Who here develops in Scala ever? Any Scala programmers? Okay, we got a couple. So some of this stuff's going to be pretty interesting for you because Scala seems to have, I guess, at least as far as I could tell, most of the interesting lightweight concurrent web frameworks at the moment that require standalone support. So just to kind of talk about these new frameworks and some of the things that they have in common. So, we're kind of looking at what they call the C10K problem, which is essentially, being able to support 10,000 concurrent connections in your web application. Just with the prevalence of all the clients out there, we all know the story there. We've talked to death about that. But architecturally, these things tend to allow you, instead of having a thread per request response model, they tend to allow a single thread to handle multiple connections. So you're actually able to scale to that level of clients concurrently. And that's typically done through a callback mechanism. And then we're finding that a lot of these frameworks have underlying usage of the Netty project for non-blocking I/O as well. So that's kind of a key component in these frameworks. And then I've got some examples listed there. Most of these are Scala, with the exception of vert.x. Who's heard of vert.x? Okay, we got a few that have heard of vert.x. So we'll actually be going into detail about vert.x momentarily. I'm going to do a demo on that. Next slide, as a matter of fact. So vert.x is basically developed, it's a community project, open source. It was developed by an employee of VMware, actually, so it's sponsored by us. But basically what it is, it's another one of these asynchronous, event-driven type web frameworks, but it utilizes the JVM. So it's similar to Node.js if you're kind of familiar with the model there and what we just talked about with, handling multiple requests with the same thread. So because it runs on the JVM, you can write your application in a number of languages that work on the JVM, so JavaScript, Ruby, Python, Groovy, Java, all options with the vert.x framework. And what makes it interesting in the model that it has, essentially each app is called a vertical, and verticals are given a dedicated thread. So, when they are actually utilizing the thread. So you don't necessarily have to worry about multi-threading in the code that you're writing to handle web requests, which is extremely valuable, actually, when it gets down to it. And then, of course, it also provides an event bus so that each vertical can talk to one another and talk to the client as well. Like I said, if you're familiar with Node, it's similar, but provided for the Java framework. And the other bit to talk about here is sock.js. Who's familiar with sock.js? Okay. It's all new stuff to you guys, great. So Cloud Foundry doesn't yet support WebSocket. There's reasons for that I won't get into at the moment, but we are looking into it. It will happen, but at the moment it does not support WebSocket. The sock.js library, however, emulates WebSocket when WebSocket is not available. So basically it allows you to have that full duplex cross communication between browser and server. So this is a nice way essentially to write your application such that when we do have WebSocket available, it just magically works for you. At the moment it chooses from a number of transports, typically long polling I think is what gets selected in most cases when WebSocket's not available. And sock.js is actually right now available for Node.js, but also available for vert.x. So if you want this WebSocket-like behavior and you prefer not to write in JavaScript with Node, then vert.x is actually a good solution for you because you can write a Java application, and it actually has some Spring integration pieces to it as well if you're wanting to keep with the Spring programming model. But you can still use sock.js for WebSocket-like behavior on Cloud Foundry. So we're going to actually dive in and take a look at this, starting with our first demo, which actually just does a little bit, but the code itself is really interesting. So let's take a look real quick. Okay, so we have this vert.x sock sample. And not a lot to this code here. So as you can see, this basically extends verticals. This kind of says this is a main starting point of an application. And you can see here in the start that we're actually creating the HTTP server here. And if you go down to the bottom, we call server.listen to actually bind to the port. And this is the first thing that's kind of Cloud Foundry specific here, which is the port that we actually have to bind to. So if you're running in Cloud Foundry, basically there's an environment variable, vcap at port. You can grab that. That's the port that you are provisioned to use. So you can bind there. And if you're not running in Cloud Foundry, you can just fall back to a local port as well. So that way this will work locally or on the cloud without modification. So that explains that part. If we go back up to see what vert.x is actually doing, We can see here that we've added a request handler. So whenever we get an HTTP request at the root level, we're just going to serve up an index.html file. Pretty straightforward. And then we're going to create a sock.js server here. And so we've implemented some handlers that are specific to sock.js. And basically what this is going to do on the server side is when data is received from the client, it's just going to write the data right back. It's just a simple echo server, because simple example, don't want to get bogged down with a lot of concepts since this is new to you guys. So if we look at the actual client side of this, which is the index.html, and we can see the sock.js configuration on the client side as well. So here we're creating a sock.js connection, giving it the URL that we're going to be deployed to. And you can see here it's the same test app that we referenced on the server side. And then we're just implementing a couple of handlers on the client side. So when we receive a message from the server, we're just going to pop up an alert box to show that message is from the server. And even though, yes, this is echo, it's interesting in the fact that basically, you're allowed push notifications from the server, kind of regardless of the fact that, yes, we happen to be sending it to the server and it's just sending it back to us. The fact of the matter is this opens up, kind of a whole new world of being able to receive notifications on the browser side. And if you're actually interested in that, Jeremy Grelly is doing a session, I believe tomorrow, kind of all about how to use push notifications in applications and the various ways that you can write that. So I would recommend that if you're interested in that. And then lastly, we basically just have our little function for sending. So when we hit the submit button with the message, we're going to send the message from the client to the server. So relatively simple, straightforward, but kind of illustrates some of the points of both vert.x and sock.js. Now, the thing that's actually going to come up again and again as I go through these demos is packaging. It's not as much of an issue if you're pushing from the Eclipse plugin, since we handle that for you. But if you're using command line tools, build tools like Maven and Gradle, there's definitely recommendations for ways that you want to package up these apps so that the bits are all packaged in a single zip file or a folder or something that's executable for Cloud Foundry. And we'll go through that in more detail. For vert.x, we actually have a kind of an interesting Gradle configuration here. So basically, we want to create a single assembly vert.x sock.js sample from the command line using Gradle. And what we want to do is actually download the vert.x distribution itself. So basically, it comes as a zip file. We're going to unzip that, and then we're actually going to place our code where it needs to be to execute within the concept of vert.x. So basically, vert.x is used to a directory called mods at the top level for all of your various modules. We're going to stick our index.html and our class in this mods directory, and then we'll just be able to run vert.x, point it at the module, and it'll run for us on Cloud Foundry. So let's go ahead and go to the command line so we can actually see that. Okay. So I believe I called the task. And this is a little more complicated than what you would normally have to do to package up an application, simply because we are writing custom build configuration to package vert.x itself. Typically that's not necessary, and we'll go over more common usage of the Gradle application plugin later, which would just basically get your classes and the libraries that it depends on packaged up, which most of the time is all that you need to do. But this is an interesting case. So if I run Gradle assemble module, which is the command that I've actually specified to do that, then it should have created a zip file for me in my build directory. Yep. So as I said again, this has got the vert.x distribution zipped up with the new module that I've added for sock.js. So now I'm going to go ahead and deploy this using our command line client, VMC. And I probably didn't mention this, but for those who don't know, VMC is a Ruby gem. So just gem install VMC, and you'll get the command line client to work with Cloud Foundry. Okay. So I'm going to do a VMC push, which will just put our application out on the cloud. And in this case, I need to pass it a path explicitly because I want it to push that zip file. So I'm going to direct it at the zip file that we just created. Okay. I'm going to name it vert.x sock sample. Okay, and now VMC is asking me how many instances of the app that I want. We'll get into scaling a little bit later, but I could decide to deploy multiple instances of this application, and Cloud Foundry would load balance essentially for me. So switching between, however many instances I have of this deployed. For now, I think one instance will serve us fine for the simple example. And now it's listing out all the frameworks that I have. If this was kind of one of the common frameworks, VMC would have likely detected it and offered me a reasonable default. Since it doesn't know what I'm pushing, it's just bits at this point, it's going to let me choose. So of course I'm going to choose Standalone. And then here's the list of runtimes that I mentioned before. vert.x requires Java 7, so we're going to go with that. And then this is where we provide the start command. So basically this is going to be anything relative to what we've just pushed out. So we've pushed out the zip file. If we were to unzip it, the command would be relative to that. So I'm actually going to run a script that comes with vert.x. I need to make sure I spell it right. Which is just vert.x. And then I'm going to tell it to run the module sock sample, since we've packaged that up in the mods directory. I'm going to double check that. Okay. Okay, now for standalone applications, a lot of times you don't need a URL. We'll see that quite a bit with the worker processes that I'm going to push. In this case, we actually do want a URL, so we can go ahead and type one out here. Memory limit, we'll go with 256 since it is a Java application. And then ask if I want to create new services for the application. So at this point I could choose to provision a data service or a messaging service, but since this is a pretty simple echo example, we don't need that right now, so we'll say no. And similarly, we don't need to bind any other services. And now it's asking if I want to save the configuration. So we'll see this later. Basically, with 11 apps to push, you guys do not want to watch me answer all of these questions all the time. If I choose to save this configuration, VMC will write it out to a manifest file, which basically just has all of the questions I just answered. So the next time that I push this app, or if I give this manifest to somebody else to push the app, all the information I need is already recorded in this file, and I can just type push, and it'll go off and do its thing. Okay, so it's uploading the bits, starting with the command that we specified, checking to make sure that we've bound to the URL that we provision. Still checking, that's a bad sign. Let's see what we did. Our assemble task might not have put the mods in the directory for some reason. So now you guys know this is actually live, and I'm not just, yeah. So let's see what we can find out here. For some reason, our Gradle task didn't copy our files over. Okay, let's try it one more time. Gradle. Gradle, build, symbol, module. I may have needed to do a build to actually get the stuff into the classes directory. Okay, so before we redo this, let's double check. Okay. All right. Should be good to go. Now we'll get to see one more thing that I am hoping will work properly. Without a manifest, I'm not sure if update will work properly with the path variable on the new option of VMC. So those who've actually used VMC before might notice that my VMC looks a little bit different. I'm actually using the next generation VMC client. So it's something that we have in beta right now. I was using it for the What's New talk, and I didn't switch out to the other one. So we've got some improved interactions, things of that nature. Architecture is a little bit smoother. Let's and apparently they've changed the update command to push, which is also good to know. Okay, yeah, it's not. Okay. See, and then I was talking to you guys about saving the manifest, and if I had done that, we would have a much quicker time here. I don't think I have it. Okay. Okay. So we're going to try this one more time, and then we will move on if it doesn't work. I was wondering if I typed the module name wrong, if that's actually why it didn't work. Save the configuration this time. Although I probably won't attempt this again if it didn't work out, but we can always come back, ooh, I think maybe it worked out this time. So I think maybe I just had a packaging issue because I didn't run the Gradle build command first, so it may have not packaged everything in the proper location for the zip file. Okay, here we go. So not the most impressive UI. We're going to get a little bit sexier with the apps as we go. But basically, here's my text box where I can send some data, and oh, it's coming back from the server. So all of that work to give you guys a very, very simple demo, but it is actually pretty powerful what's going on here in terms of kind of the next-gen web application architecture that's being defined. So we shall move on from vert.x. And on to the next category of applications, what we call bring your own container. Okay. So there's a number of different reasons why you might want to bring your own container to Cloud Foundry. One of them, for example, is the framework programming model, and we'll have a sample of this in a second. Some frameworks, like Unfiltered, which is another Scala web framework, it works really well to just use their embedded Jetty support and start your application with a main and bring Jetty with you, as opposed to trying to get it packaged into a WAR file. So there are some other frameworks, or perhaps you're just dealing with an application that was written in such a way that it's easier to use an embedded Jetty than it is to package it as a WAR. That's one good example. Sometimes the Cloud Foundry engineers can be a little slow. We don't yet have Tomcat 7 available. So at the moment, if you push any of your web applications using those standard web application frameworks, you're going to get Tomcat 6. So if you're trying to work with Servlet 3 at the moment, you do need to bring your own Tomcat 7, although that's not long term. We will provide it for you. And actually, there was a community blog recently that went through the steps on how to do this. It's fairly straightforward. Maybe you want to be on the cutting edge. So one recent community blog as well was done about Clojure. So basically just deploying a Clojure app onto Cloud Foundry using the standalone support. A couple other reasons, maybe you've got some legacy HAB apps hanging around. I hope you don't, but if you do, there was actually a recent blog post by someone in the community about using Tommy on Cloud Foundry. So that's a possibility as well. And then you may also just want to customize Tomcat beyond what we allow you to do. So in some cases, if you need to really have like some customized logging and get into the Tomcat configuration, like the server XML or those types of things, that's not something that we at the moment expose if you're just using a typical web framework. So if you were to package your own Tomcat, this would allow you to pretty much put whatever you want in the configuration. One really interesting example of this that went around recently was using hot reloading. So somebody had come up with an application where they exposed a REST endpoint to upload single classes as opposed to going through the VMC mechanism to update an entire application. And then that was triggering a Java agent to kind of recompile and hot reload on the fly. A little advanced, but it's an interesting application of the kinds of freedom that you get with BYOC. So we're going to do another kind of simple example. We're graduating to more complicated stuff shortly. I'm going to show you unfiltered with embedded Jetty, so you get a feel for that. This is another one where the app doesn't actually do much, but it's interesting what's going on. So this is all Scala, so I guess not going to look too familiar to most people in the room, but I think the general gist of it will stick. So this is an unfiltered application. It's a class that extends what they call plans, and they have plans for Jetty, but they also have plans for Netty if you wanted to use the asynchronous non-blocking I/O as well. So again here, what you're probably going to expect to see is us configuring the port. This is going to look familiar, same as the vert.x sample. So here you can see this is the main method that actually gets launched when we use the unfiltered example. And it's just dealing with the unfiltered.jetty configuration directly. And again, giving it this port that we provision for you when you deploy to Cloud Foundry, vcap app port, or a local port if you're running locally. So kind of the same principles. You'll see that over and over again throughout the demos. And then basically here, we're just handling the REST requests here. So in the case of get, we're just rendering a view. Post, we're actually doing some things, etc. So this is essentially all of the controller logic in this single Scala file as well. Okay. So we're going to use the command line one more time before we switch to the STS view for the rest of it, just so you guys can get a feel for that. Okay. So this time, I'm not going to go through the interaction. I'm actually going to use a manifest. So let's take a look at that. Okay, so this is a manifest that was created for us by VMC. Of course, it's a simple text file, so it's possible to create one yourself as well. And this is kind of all the answers to the questions that you saw previously. So I've got standalone framework, Java runtime, low amount of memory. So Scala apps tend to take up less memory on the lightweight web framework side. Again, I provisioned a URL. I've given it a path to a zip file. I'll talk about that in a second. And then this time, my command is actually a Java command. So I'm using an executable jar that my build system creates that contains that main that we just looked at. And then one thing to note as well is that I'm providing the Java ops environment variable. This isn't necessarily something you're required to do, but we do recommend it for standalone applications. We set Java ops based on the memory that you allocate. So here you can see I'm going through the standard Cloud Foundry mechanism of allocating 64 megs of memory. If I use Java ops environment variable in my Java commands for standalone, the min and max heap are set accordingly. Similarly, on local clouds, we offer debugging, which I hope to have time to show you later. So you can basically say, I'm going to just through VMC start in debug mode, and all the debug params are going to come through on Java ops as well. So if you want to be able to remote debug your standalone application, again, we recommend Java ops. And you may have noticed that wasn't an issue on the last sample. And there are plugins that create distributions that have start scripts or things typically include Java ops for you. So it's just the case more than likely if you're actually doing your own Java command that you'll want to include this. So hopefully you don't have to interact with it too much. And STS does this for you automatically, which we'll see as well. So since you guys aren't too familiar with Scala, SBT, the Scala build tool, is probably also something you're not too familiar with, but just in case you get into it a little bit later, just want to point out that what we're actually using for distribution is the SBT package dist plugin. It comes from Twitter. And actually here, I think the only thing that we had to configure on it was a name. So if we were to run SBT package dist, again, we're creating a zip file. This pattern's probably going to get pretty familiar to you guys. A zip file, a distribution directory, something with all of your stuff packaged neatly together on the binaries that you can push out to Cloud Foundry. Okay. So this time all I have to do is type VMC push and the magic automatically happens, which is good. And again, we're not consuming services yet, so these are still some simple examples, but we're going to get there. Question?
You had already done the build.
Yeah. So if I had wanted to do the build, I would have done well, SBT compile as well, and then just SBT package-dist, and that would create my zip file for me. Okay. So now we're going to get our super simple unfiltered application here running on embedded Jetty. Okay. So once an integer and a palindrome, let's see. And it confirms that Bob is in fact a palindrome and 3 is an integer. So again, simple example, but just really illustrates the power of, using these web frameworks that require mains, essentially, new and different ways of launching standalone applications. So we're actually going to move a little bit more away from the web framework side and to talk about distributed applications in general, and specifically using distributed polyglot applications and the kinds of things that we can provide there. So we're going to start just by kind of talking through some architecture. So this is kind of your traditional old monolithic WAR file for a storefront application. And actually, I'm going to be using several incarnations of an app called Widgets and Gadgets Are Us. Does anybody know this app? Oh, good. Okay. It was utilized for a few examples last year on Spring Integration side, and so I wasn't sure how familiar you guys are with it. But basically, it's a storefront. It's an online store that sells widgets and gadgets. And so we're going to talk about the architecture and then kind of walk it through several different breakdowns using the standalone support. So this might be how you would develop, at least back in the old days, how you might develop widgets and gadgets as a single WAR file. So you'd have a controller that handles all the requests at the front that are coming in from your web application. And then you'll probably have a number of back-end services to handle, making sure you've got widgets and gadgets in inventory, the billing and the shipping, and they're all talking to the same relational database. So what's wrong with that? A lot of things, at least in this day and age with modern web applications. So the first, of course, is a problem with scaling. Yeah, you could replicate the entire system itself for scalability, but it might be nicer to actually be able to scale up certain components. Perhaps there's things that just have more of a load on them that you want to scale as an individual piece, as opposed to the entire thing as a whole. And then a bigger problem, of course, is you have to deploy the whole thing in one go. So if you've got multiple teams, for example, on these large applications that are working on your different services, then you're going to be required to essentially, in order to deploy updates, all of you guys are going to have to coordinate and make sure that the entire WAR builds fine and then gets redeployed. And it's definitely increased risk of something breaking as opposed to keeping your components nice and separate and being able to do actual continuous deployments of those isolated components by themselves. And then, of course, there's a problem with applications being brittle. You've got everything running in this one container. All of their services have to be available, and any single failure, like a memory leak, is going to cause everything to go down. So there's not going to be any chance that you could have one component maybe kind of, come back online and then do the shipping based on the orders that you've taken while that piece has been down. It's kind of an all or nothing proposition. Basically, your whole app works or your nothing works. And then, of course, these days we like to be polyglot. So, there might be other languages in which parts of your application are better suited to be written, different frameworks maybe that you'd prefer to use. And with a distributed approach, that's obviously a lot easier than trying to deploy all of that into a single WAR file. And I'm probably preaching to the choir. I'm sure you guys know a lot about this already. But just to kind of touch on why this is important, again, so many different clients out there now with mobile, HTML5, desktop, and we've really moved towards more of an asynchronous messaging-based architecture, which we're definitely going to cover in the demos with widgets and gadgets. And of course, now with all the different NoSQL options that are available to you, it's not necessarily true that every component of your application needs to store things in the same way. You might be utilizing different stores for different types of data, key value, document, relational database, whatever it's suited for. Okay, so how do we address this problem? Well, here's our app at the moment. It's monolithic, just kind of sits there. One thing we might do, at least, is kind of break it up into multiple back-end services that talk to each other and to the front via a REST API. So some type of HTTP request to at least get these things separated out. And so then, of course, we could start to think about scaling the front end and the back end independently. So maybe, as I mentioned before, inventory, it might make sense to have a few more guys listening to that versus shipping or what have you. And with this type of approach, we can scale, and then of course scaling on the front end is something that you would definitely want to do potentially in isolation of some of the other services as well to handle your web load. So in Cloud Foundry, scaling is easy, scaling out at least. So that's use the VNC instances command or an STS is also applicable too. So for any application that you have, you basically can just say, give me X number of instances running of this application. You can use a hard number or you can say +1, -1, etc. And what that's going to do is it will spin up and run that many instances of your app and then essentially we will just balance via load balancing as necessary. And in some cases, if you're actually scaling up a worker process that's not a front end, let's say that you actually have several workers that are doing jobs off of a queue. It makes sense to scale those if you're able to do concurrent processing so that you get things done faster. And that's kind of the point of what we're going to be talking about with scaling out. And if you're in an architecture like this where you kind of have the front end dependent on the back end via REST connections, the manifests do support that kind of depends on notation. So we could very easily push multiple applications out with a single manifest, have that dependency represented, and make sure that everything is where it needs to be at deployment time. So what would this look like if we changed our architecture to do this? So basically now what we have is we've got a store running as a WAR file by itself, and it's communicating with our inventory services via a REST API. And those in turn are communicating with billing, which might be a WAR, and shipping, which could be whatever as well. Also, again, at the moment, via REST. And then you can see that each of these components are utilizing a different data storage that makes sense for them. So we'll explore the app a little bit, but basically the inventory service uses Redis just to maintain counts of what products are available. So how many widgets and gadgets do we have in stock? So for a simple counter, it might make sense to use a key value storage. Whereas shipping actually is going to store all of our order information as a document in Mongo. And there's easy support with Spring Data to do that seamlessly. But we'll see it actually stored in a variety of different ways as we go through this. So let's go ahead and get started with the first of our 3 breakdowns of widgets and gadgets. So now we switch to STS, done with the command line for the moment. And we'll close you out. Okay, so let's start by looking at the store, which is just a simple Spring Web application. So we have one controller at the storefront. And this guy just basically parses all the request parameters and creates this order object. And then it'll use a REST template to communicate via URL to our inventory service and actually send out that order information. So whenever I place an order at the store, it's then sent along to the inventory service. So what we've done with the inventory shipping services is we've decided to go totally polyglot, and we've written them in Scala using a lightweight framework called Blue Eyes, which just makes it really easy to do simple REST handling on top of Akka. Of course, many, many different ways we could have done this. This is just one example. So let's actually look a little bit more at the inventory service and see how it behaves when it receives that request from the storefront. So one of the first things that you'll notice is now we're actually starting to interact with services. As I mentioned, the inventory service is going to use Redis to store a counter of the inventory that's available. So in order to do that, we're utilizing the Cloud Foundry runtime library, which we actually provide. It's in the Spring Milestone Maven repository. And what this does, at least in this case, is that we can programmatically grab all of the Redis services that are bound to our application and get data about those. So if we find that we actually have a Cloud Foundry Redis service available, then we can create our Redis connections using that information. So we're getting like the host and the port and the password and all the things that typically come from environment variables available to our app. We're able to do that programmatically and make that connection to our Cloud Foundry Redis service. And then, of course, we can also fall back on local if we find out that we're not in the cloud environment. So again, we're able to run the application in both contexts. So let's actually take a look at what's going on here. So this is where we have the request processing for the orders endpoint. And we're just going to print out that we received the order, do a credit check, which goes to the billing service, which I'll show in a second. It's actually not implemented, so everybody is approved today. So then we're basically just updating some of the message information. We're saying, yes, this order was approved and reserved. And then we send it off to the shipping service via REST as well. So if we go down and actually kind of look at what's going on here. In the reserve method, once we've decided that we actually have widgets or gadgets available to us, we're interacting with Redis, and basically we're just decrementing that counter on the product ID. So product ID is either a widget or a gadget. Those are the only two things we sell. So basically we're saying here, okay, in order to reserve, I need to decrement that counter on Redis. And that's just done through normal Redis access libraries within Scala. And as I mentioned, there's a credit check method that could go to a billing service. We didn't actually want to add real billing here for a demo application, so everybody's approved in the demo world. And then here we're actually using a Scala library that does REST client to make the connection to the shipping service. So again, we've got the URL that we're going to be running the shipping service at, and we're going to pass the order information along to that shipping service as JSON from an object. So a lot of these concepts are probably pretty familiar, regardless of what language you're actually coding your web applications in. Okay. And I won't show the shipping service, but essentially it does the same thing. It receives the order, and then it actually writes out the data to Mongo. And I'll show that a little bit later in the Spring form. It's a bit more interesting there. Okay, so now we need to get all this stuff deployed out to Cloud Foundry. So we'll start with our inventory service. Just going to drag that. Actually, before I do that, let me delete my applications here so I don't run out of memory. Okay. And make sure I'm not forgetting any steps. Okay. Yeah, one thing I did almost forget to show you guys. So with the new standalone support in STS, basically in order to allow us to use WTP to drag standalone applications down to a Cloud Foundry server, there is a one-time step you need to do. And there is a configure menu item here. So you would see enable as Cloud Foundry standalone application. And this just allows Eclipse to be able to work with this project as though it were a WTP project. So I'm going to drag that here, and we can see it's a standalone application, so it's not showing us a framework, but it is going to be asking us for a runtime, and Java 6 is fine in this case. Okay. And obviously we need a very specific URL here because we're configuring everything to talk to each other via URL at the moment. So I'm going to provide one. We're going to move the memory way down on these guys. So we're down to 128 here. And so you can see basically that STS kind of knows that I'm launching a standalone Java app. If this was not Scala, it would have auto-detected the main type. We don't yet have support for auto-detection of Scala mains, but you'll see a little bit later that Java mains, it'll just come up right away, so I don't even have to type that part out, which is good for limited memories. In this case, I need to type the main. So this is just that server class that we were looking at that actually starts up the services. And as I mentioned before, the nice thing about this is that you're not worrying about packaging. So basically, it's already created the Java command for you. It's put Java ops in there. And then it's going to take basically every dependency that you have on your build path, copy it to a libdir over on Cloud Foundry, and it's already added that to the class path. So everything that I need for this application, all my dependencies, including the classes of the application itself, are going to be available and pushed automatically. Okay. And now it looks like we're going to need to provision a service. So we are using Redis here, so we're just going to call it inventory, create a Redis service, and then it's checked, so it'll be bound and available to our application. And now we should be able to push. And while that's going, we'll go ahead and take the store. So the store is a Spring Web application as opposed to a standalone app, but deploys the same way. The default URL here is fine, default memory, etc. for the Java web applications. Okay. And this guy doesn't use any services, so we can just go ahead and click finish, and that'll get our storefront up. You can see from the console that was just there shown that our inventory service started up okay. And then lastly, we need the shipping component in place, since we can't get through a workflow without everything being available at the moment. And it's enabled, so we should be able to drag it and deploy it in the same way. Okay. Again, I need to provide a very specific URL for this since everything's communicating via REST. And it's structured the same way as the inventory service, so the name of the main type is the same. And it wants to store shipping data in a Mongo database. So let's give it a Mongo database to store shipping data. And now we're finished with that. So while that deploys, we'll take a look at our store here. So once again, I've brought up the various cloud screen. I can hit the store URL. Okay. There's our pretty little store interface. At least it looks a little nicer, has some graphics this time as opposed to the other ones we've been demoing. But of course the order flow is still pretty small, so I'm going to give a customer name, and let's see, I'll have 2 widgets at my store. Okay. So you can see it paused for a second and then came back with my order number. So basically, because right now I'm doing a connection to each service via REST, the whole thing is a synchronous operation. So, when I actually got my order number, the order had made its way all the way through the system at that point. And if we go back to the logs, we can confirm. So you can see here in the shipping that we did, in fact, ship the order. And inventory would probably have a similar confirmation message for us. So we have a decomposed application now. We're able to, if we wanted to scale any of these individually, we're able to easily do that. And everything is still talking to each other, of course, via REST interface and synchronously. So you can imagine that there might be ways we could improve upon this architecture. Okay, how are we doing on time? I'm only halfway through my 11. Okay, cool. Okay, so another example that we actually have is with Akka. So basically Akka for Scala developers is essentially an actor-based system. So if you're familiar with the actor pattern, Akka employs that. And there's a number of ways to scale Akka, but essentially you can scale the actors in Akka up, which basically just means you're using, you have multiple instances of these actors that perform tasks, but they're all, on the same node, just using multiple cores, and there's a routing system in place for Akka to do that. But Akka 2.0 also has a concept of remote actors. This allows you to actually scale out. So we'll be going through this really quickly. It's a similar example to what we just did, but just kind of seeing, that you can actually run Akka on Cloud Foundry, which was not something we could previously do before standalone support. So we have a new architecture now for our widgets and gadgets store that's based on Akka remote actors. And kind of the key thing, just to summarize as best I can for those not familiar, the key thing about remote actors is basically that your front ends kind of have a remote reference to the actors on the back ends. So it's almost like a point-to-point communication. So obviously in the cloud world, you don't necessarily know what URL and port these actors are going to be running at. They could be assigned pretty much anything. And when you scale up, again, you're really not going to know what Cloud Foundry has assigned them ahead of time. You can't just pick static IPs and ports. So this particular architecture we kind of developed as a test theory, just to say, what if we took a Redis store and we had essentially all the actors register their IPs and ports in Redis, and then we could use a routing actor that would go to Redis, look up the hosts and ports of the available actors, and just route us to the appropriate one to perform a task. And you can imagine that you could also do something like this with a messaging-based system like AMQP. I think at the time that we wrote the sample, Akka 2.0 did not yet have the AMQP module fully baked. And in fact, it's not, I still don't think it's available in the distribution, but I have seen branches of it. So you may see another incarnation of this in the future that uses messaging as well as opposed to Redis. And this one's not quite as involved because we didn't go through the whole store implementation with Akka, just to kind of give you some of the basic concepts here. So starting with the ordering actor. actor, let's take a look at what we've got here. This is equivalent to our inventory service, basically. But this time around, we've turned it into an Akka actor-based system. So this is kind of the back end. This is like the main that's going to get started to actually bring up our inventory workers. And what it's going to do is it's going to set a couple system properties for the host and port. And it actually just uses a little library that we wrote to grab whatever port might be free and use that. And then here it actually starts the Akka actor system, which just takes the configuration and gets the Akka actors going without getting too detailed there. We'll look at the ordering actor next and kind of see what it's responsible for doing. And basically, actors work by message passing. So whenever the ordering actor receives a message, it's going to perform the actions that we have required of it. So let's see what we have required of it. Okay. So you can see that actually when it starts up, before it receives any messages, this is the key area where it's going to put its host and port information into Redis for the store to find. So the store basically is going to use a router that needs to understand, where these actors can be contacted. So they're saying, I'm here, registering with Redis as they come up. And then when they receive a message, basically at the moment all they do is print a message that says I'm processing the order. So, probably not exactly what you're expecting if you ordered a widget or gadget and it never gets delivered to you, but you can kind of see how we could fully implement this in the same way that we did with the previous example. Okay. And then again, if you just want to see how we're actually communicating with Redis, as you can probably guess, it's the same type of way that we did previously where we were using Cloud Foundry runtime lib. So again, we're getting service information about a Redis service that's bound to the application, and then we're creating the service. And this Redis service creator is actually something that we provide for you in the Cloud Foundry lib that takes care of setting up Redis connection factories using Spring data. Okay. So in a nutshell, that's pretty much what the ordering actor is doing. So we can go ahead and start one up so we have some order processing going. And this is going to look familiar because it's the same way we've been doing it this whole time. Okay. So this time I actually don't need a URL. I'm not using REST anymore on the storefront to communicate to the ordering system. I'm using the Akka remote actors instead, so we can skip that part. But again, because this is Scala, we actually have to enter the full name of the main for now. Okay. Make sure I got that right. Okay. And obviously we need a Redis service, and call it Redis actors. There. Actually meant to adjust the memory down a little bit, and we still might not have enough with all these other apps to play, but we'll see if we get that memory before I can delete the other ones. Fingers crossed. So I'm actually using my microcloud for provisioning, and oh good, it's there. Which is just the VM that's running locally, basically all of Cloud Foundry locally. Mostly do that when I'm doing demos because it supports offline capabilities, so if I lost my internet connection, I could still demo to you guys. But the memory is sometimes a little bit limited just because it's a 2 gig VM for all of microcloud. So we got that one done luckily, so let's go ahead and delete our old ones, which I meant to do before we started this, just to make sure we've got enough space. Okay, so now we revisit our modified storefront. It's still a Spring Web application. We've just slightly modified the controller to deal with the remote actor system instead when it needs to forward an order. So if we take a look at what this guy's doing, basically it's creating a remote routing actor. This is the actor that takes care of looking things up from Redis and forwarding our request as appropriate to whatever actors are registered. And that just happens when we actually initialize the storefront. Then when an order is placed, we essentially just use the message passing here, routing actor.tell, to send the order information as a message. And basically this is just an object around the JSON that we receive when the order is placed at the web level. So of course, a similar approach, we're passing the data off as it's done, but this time we're doing it asynchronously and through the use of the actor system, which could basically, if a particular actor goes down, for example, on the ordering side, it would then just route us to a different one. So, we've got a little bit more fault tolerance than we had previously, although of course we could have scaled up at the URL level as well. So again, asynchronous really here is more the benefit when moving to the Akka model, and then we're going to go even further in the next incarnation to kind of break that last little brittle bit around the connections between the services. So this guy gets deployed out the same way again. Okay, general URL, all good. We need to bind it, of course, to the Redis service so it can look up the actors that it wants to talk to. We should be on our way there. Okay. Looks like everything came up all right. Let's hit the URL. Order some gadgets this time for Bob. Okay. And, it's not a very complicated process to begin with, so you might not have noticed that was quicker, but it was a bit. And then if we actually go look at the logs of the ordering system, we should see that it received our order and processed it. So let's see here, process the order. So that's basically just kind of another incarnation using Akka for those who are interested, and maybe it'll inspire you to look more into Akka or the Scala development in the future. But now let's move on to the stuff that you guys probably really want to see, which is a Spring integration implementation of this. So I've kind of already touched on the fact that, while this is a good implementation, you are relying at least on one instance of these services being available. So even though we can scale, say, the inventory or the ordering service, and we can handle, multiple nodes and deal with some fault tolerance, what if they all went down? I mean, granted, hopefully that doesn't happen, but we're still a little bit brittle because we've still kind of got point-to-point communication there between the various application components. So what if we were to take this and use a messaging infrastructure instead in such a way that components can completely come and go, and then as they re-register, they can pick up whatever messages they've left behind and keep processing appropriately. So this is the revised architecture for that case. So basically we're dealing with a message broker, and everything is sort of communicating through the message broker to the other components that need to pick it up. But the rest of the implementation is more or less the same, although implemented in a different language. But we'll see. So we're going to use Spring integration for this. One of the great things about using Spring integration in this case is essentially because of the loose coupling, we basically can have these apps exchange messages with one another with having no idea what the transport mechanism is. So I can write these three apps in such a way that they're just dealing with the fundamental concepts of Spring integration, one of which is a channel, for example. So they're just essentially putting messages on a channel, receiving messages from a channel, but they don't necessarily know or have to care what is powering that channel, whether it's RabbitMQ or whether it's a JMS infrastructure. Maybe they're receiving an email and the data is coming in that way. So Spring integration makes it so that your app logic really doesn't need to care about that and can focus on what's important to the application. And we'll actually go through the configuration and see how that's done. So as I mentioned, kind of the key concepts are channels, which is the virtual pipe for the producer and consumer, and then endpoints. And basically there's a number of endpoints that come out of the box with Spring integration that just allow you to do things automatically with the messages that you send and receive. And there's several examples of that, but basically just you can reroute a message, change it, split it, etc. With Spring integration. Okay, so let's take a look at this app one more time before we move on, but this time written all in Spring and with Spring integration. So again, we'll start by looking at the inventory service. Actually, no, I think I want to look at the store first. So store is still a web application. We haven't changed that. But let's take a look at the configuration. So if we go to the Spring Beans file, we can kind of get a feel for how we're configuring Spring Integration to work with the store. So basically here we've defined a couple of channels. So the order channel and JSON orders. And I won't go into too much detail about what the claim check does, but basically there's some amount of message transforming going on when we take in an order and then place it on the queue. So this is the interesting part here, is the outbound channel adapter. So we're going to take that order information the same way that we have been doing from the store, but instead of passing it on directly, we're going to basically just put it in the message queue using this outbound channel adapter via the Rabbit template. Similarly, we're actually going to have persistent messaging. So we've got a Mongo service that we'll utilize that'll allow us to store messages for long-term persistence in case something goes down and we need to retrieve it later. But again, this is all kind of just happening for you based on the configuration and invisible to your application logic. And so here we actually see the first usage of Spring profiles. So profiles were introduced in Spring 3.1 and basically allow us to have different bean definitions depending on the environment that we're running in. So if we were to be running this application locally, we could configure local Mongo and Rabbit connections using the Spring Data namespace in this case. But if we're running in the cloud, then we can actually connect directly to our Mongo and Rabbit cloud services through the use of the cloud namespace. And again, this comes from the Cloud Foundry runtime library. So if you were to utilize the cloud namespace, we take care of finding the service for you and actually creating the Mongo connection using Spring Data to that service. So this is really all that you need to do to be able to switch your application back and forth between local and cloud development, is to change your profile. And if you're deploying a Spring web app, we actually do that automatically for you. It's one of the things I mentioned, that kind of the special support we provide. We automatically activate the cloud profile. With Standalone, since again, we don't really know anything about your bits, you need to do that yourself, but it's relatively straightforward. And I'll show you that in just a second. So first, let's actually look at the storefront one more time. Okay. So in this case, we just have a messaging template. And again, that's a generic interface. So the underlying infrastructure could be just about anything. So we happen to know from the XML configuration that we're passing it a Rabbit template. But again, that's not something that our class needs to know about. So we know, we're receiving the order. And then we're just passing it along to the messaging template. So this will put it on the Rabbit queue, thanks to our configuration, to get picked up by our other services. So let's take a look at one of our other services. Let's look at the shipping service, since we really haven't explored that one yet. So these incarnations are standalone apps, but they're written in Java this time. And they have similar configurations in the Spring context file. So we're still dealing with, this time, of course, we have an inbound channel adapter, which is the order channel. So this is going to basically subscribe us for those orders that are being placed by the store. And then similarly, we can use the persistent message store, et cetera. And our Mongo and Rabbit connections, again, are being enabled through the usage of the cloud namespace in our cloud profile. And since this is a standalone application, because really we don't need web services at this point, this guy just is going to receive messages from Rabbit and act accordingly. So there's really no reason to have a URL of any kind. So we just have a very small main that'll start this up. And essentially all this is doing is checking if we're in a cloud environment, again, using the Cloud Foundry runtime library. And if it is, then we just activate this cloud profile via a system property. Then we just create our class path XML application context as you would for any standalone Spring application. And we're off and running. So if we actually explore what this shipping service is doing, since we didn't look at it previously. So basically, it, again, is interacting with Mongo via Spring Data interfaces. So it's using a Mongo template here to save our order. And basically, due to our configuration, our messages from Rabbit are automatically being routed to the ship method. I didn't show you that in the XML file, but basically it's set up such that whenever a message comes in, this method's just automatically executed. So when we get the order, we make sure it's approved and that we've reserved the inventory, And then we just save it directly using the Mongo template. So we're actually taking, an order object that was created from that JSON and persisting it directly to Mongo without having to transform it into a document. So this is all courtesy of Spring Data and Spring Integration. So it makes it really, really simple to deal with these types of NoSQL data stores. Okay, so my wrist is starting to hurt a little bit from dragging and dropping, but we're getting close to the end here. Let me delete these two guys. Free up some space. Okay. Don't even have to talk to those first screens anymore. You guys are probably really familiar with them at this point. Okay. But we do need to configure a couple of services. So of course we need the Rabbit service to actually provide the messaging. And let me just make sure I don't need to name it anything specific. Okay, I don't. So we'll just call it messages. Okay. And then we also need the Mongo message store for persistent messaging. And we'll see why that's interesting in a second. Okay. And while that's going, I'm just going to go ahead and do the inventory service as well. So as promised, it did detect the main automatically this time around since it's a Java application. So this is the demo that I just showed you that basically just initializes the application context. And again, we don't need a URL this time. This guy's headless. He's just working off the message queue. But we do need to, of course, give him the same access to the messaging services. Okay. So we'll wait just a second for that to boot up. And then let's go ahead and visit the store without deploying the shipping service, just to prove that it's really as asynchronous as I say it is. So let's have Joe order a gadget. Submit. Joe's got his order number. Okay. We've processed it in the inventory service, but we haven't yet shipped it because we don't have the shipping service available. So let's go ahead and deploy that. Again, my main is auto-detected, which is great. I'll bind here. Okay, so the shipping service should come up and hopefully tell us about shipping an order momentarily. I believe it prints out a message. I should double check that. Yeah. I wonder if it got lost up here somewhere. Oh, it's going to make a liar out of me today. It does normally do that. Maybe I messed something up when I was coding it. We'll just do another one real quick. See if it's listening. Yeah, it actually looks like it's just not processing shipping at all at the moment. Okay. Anyway, you can see the idea that the various components would actually be able to come up and go in isolation, reconnect to the message queue, receive their orders, and then process. So we can kind of already see how this is a less brittle architecture than the ones we had previously. But I am definitely running short on time because I have one more interesting thing to show you guys. One more thing I should show you, though, while we're here, just because I actually haven't demoed it yet, I just keep talking about it, is the scaling aspect of it. So as I mentioned before, it's really easy to scale in Cloud Foundry. So if I wanted multiple instances of my inventory service, for example, I could just here, yeah, I'm running short on memory. But I could just here adjust the number of instances, restart, and those would come up and basically balance between the two. And if you went to boot camp, you probably saw a good example of that. We tend to run just a quick sample where the IPs are showing up in the browser, depending on which one you're hitting, just to prove we do actually balance between them. But essentially, that's all there is to scaling. Yeah.
Does it actually restart, or is it just starting up another instance?
When you scale, it's starting up a whole other instance. So you actually have two processes running.
But the first one, it doesn't restart?
No, the first one just continues to run. Yeah. Okay, so the last application of standalone applications, and I do want to get through this is a pretty interesting demo too, is workers. Who's familiar with Spring Batch? Okay, we got a room full of hands. All right, so I'm just going to give you a really brief introduction to Spring Batch and why it's useful. So workers tend to be processes that we think about that, do work, right? Headless processes. They might do things overnight for you, like updating your search indexes or mass emailing your users. They can be doing things asynchronously in response to shared messaging. There's just a number of applications for workers. I'm going to skip that since we're running short on time. So one of the things that actually, makes sense from a worker standpoint is batch processing. So basically batch processing, kind of anything that you're doing offline at night probably that involves large amounts of data. So there's enterprises that are just, processing thousands and thousands of transactions using batch processing offline. And Spring Batch is actually a library that was kind of developed with batch processing concepts in mind to allow you to, write your application in the same Spring style where the underlying infrastructure is irrelevant to your components, but you can actually then perform batch processing with Spring Batch. And there's a couple of concepts to it. Basically, you're just defining a job that needs to be performed, which has a number of steps within the job. And then you have a launcher that launches those jobs. And then generally a step does kind of three things. It's going to read data from somewhere more than likely, and then optionally might process it, change it in some way, filter it, and then write it back out. So an email was an example. You might have an email writer implementation. So you might be processing like large amounts of data and going through and emailing customers accordingly, and that would be your writer. Best illustrated with an example, my last one. Might get it in just under the wire. Okay. And I know you guys said you weren't working with Scala, so I probably know the answer to this question. But is anybody taking Martin Ojersky's course on Coursera on Scala? Okay, we do actually have a couple of people in the room. So this example was inspired by a recent assignment that we had to do in that class. So basically it was taking a very large amount of tweets. So we have a file that's just full of data that was extracted from Twitter. We're not going to worry about how that file got there. There's many ways we could implement that. But basically offline at night, we want to go through these tweets and look for ones that are relevant to our company using like a number of search terms. And then we're just going to persist that data into a relational database, essentially, with this example. Time is short, so I will try to briefly explain this. All of our beans are basically specified here in the single context file. Once again, this is a standalone application, of course. So let me just show you. Here I'm using the batch namespace to specify the job that we want to have performed. So basically we're saying for this particular job, I have a custom file reader, a processor, and a writer. So again, reader's going to process that comma-separated list of tweet information. Processor's going to filter it out for our search terms, and then the writer's going to write it to the relational database. And just to give you a sample here, our processor here has the search terms configured that we want to look for, so kind of Google-related terms, Android, Galaxy, Nexus. We find any tweets in our large file that contain these words, we're going to put them into the relational database. And in the interest of time, I'll show you just one class that facilitates that. So we're making use of the Spring scheduled annotation, which is extremely valuable for pretty much for any of these types of jobs that need to be run at a given time or at a fixed rate. As the comments indicate, more than likely you'd use a cron style thing and run this at like midnight every night or whatever. But for the purposes of this demo, we're actually going to run it every 10 seconds. So we know that it's going to be done quickly once we actually deploy it out to Cloud Foundry. And I am going to actually be posting, most of the demos are already up on Cloud Foundry samples and GitHub, but I'll post the rest of them. And when I link the slides up, I'll have a link to them so you guys can explore this one in a little bit more depth when we have more time. And the other thing to note is that we were again making use of profiles to initialize the database, so we can use it locally with an in-memory database, and then we can also push it out to Cloud Foundry. In this case, we initialize our tweets database with MySQL, and that's just a simple DDL that creates the table, and we're storing the number of retweets, who tweeted it, and what the actual tweet was. So one last time, we're going to deploy to Cloud Foundry. Free up some space. Okay. And I'm starting to get all my applications mixed up with doing so many of them, so I want to make sure I do this properly. Okay. Nope, I didn't enable it. There we go. Okay. And since this is just batch processing, we don't need a URL. Mains detected, so we're good there, but we do need a MySQL database to store our tweets in. Tweets. Okay. So we'll deploy this out, and we should get a log message that it's starting to actually process those tweets. At the moment, it's just going to keep storing them in the database, so our database actually might get kind of big. But obviously that's pretty fixable. So you can see here, it's running every 10 seconds. It's telling us it's running the populator. The job is exiting as completed. But let's actually confirm that we really have those tweets in the database. So this is where we use the tunneling that I was telling you about before. So we can actually connect directly to the MySQL service and see those tweets for ourselves. So we're going to run VMC tunnel. We say we want to tunnel to the tweet service. And then it gives us the number of clients we could launch. Of course, we could pretty much launch whichever we wanted, but MySQL is fine. So it should open up this tunnel for us so that we can actually look directly at the contents of our MySQL database. So if we select star from tweets, you can see we've got 190 tweets processed. And I think the line, I had about it wasn't a lot, it was about 700 tweets, I think, in the actual tweet data file. But basically, that quickly it parsed through all these tweets and picked out the ones with the search terms that we care about. Yeah, 700. And we're able to view that with Cloud Foundry. So that's just one more example of how you might deploy workers onto Cloud Foundry. And the rest of the slides, I believe, are mostly for reference. It just goes over the various packaging options for each of the build tools that you might use in Eclipse. And then, of course, I've talked to death about the Cloud Foundry runtime jar, so I don't think I need to cover that anymore as well. The one thing I think on the practical tips that I didn't mention before that's worth noting is that this type of application needs to stay alive. So you might be tempted to use this to deploy something that's going to just do one task and then die. The only problem with that is that Cloud Foundry will think it crashed and it'll keep restarting it. Maybe that's fine for you if that's what you care about, but just to let you know that typically we're expecting long-running apps with this. And there's a number of ways you can accomplish that. Like I said, if you have a periodic task, you can just write a Spring app with the scheduled annotation to have it perform periodically, etc. But just a note on that it will think your app has died and restart you. So here's our key takeaway. Hopefully, with all the 11 apps that I pushed, I showed you guys there's all kinds of possibilities on Cloud Foundry for standalone applications. And if you want to learn more, I do recommend these two sessions in particular that are going on tomorrow. Chris Richardson has a great session on decomposing applications where he'll really go into that architectural breakdown that I touched on today. And then Josh has a whole session on batch and integration, specifically on Cloud Foundry, so you can get more detail on those as well. And I know I ran long, so I have just a couple minutes for questions. Does anybody have anything? You can come up and see me afterwards, too, if you'd rather. All right. Well, thank you very much. I appreciate it.